Hello, everyone. Welcome to the Recitation 0 about Git. Today in this recitation, we're going to walk you over what Git is and how to use Git, and especially how to host your Git repos on GitHub, which is technically separate from Git, but then these things always go together. And I'm Josh.
Hi, I'm Harshit.
Right, and we're going to walk you through what I just talked about. So, all right, so first of all, what is Git? Git is what's called a version control system. And what is a version control system? It is a software that you use to keep the versions of your source code. So let's say you're writing code, right? And let's say you add a new feature and you found out that code you added for the new feature completely messes up what you had from before. So then you want to revert to the version of the code that you had before you added the new feature. But it's also very hard to find out each place where you had inserted your code for the new feature and manually delete them. That's why we have Git. So because the idea with Git is that whenever you add a new feature or you complete what's called a snapshot of your program, which basically means you think your program is in a state where it's functioning properly, you will save the version of that state. So then when anything happens, you can conveniently revert your program to the earlier state, right? That's the very basic idea of what Git does. And when you use Git, you will be able to revert to past versions of your code. And it has the added benefit of when your computer dies, which happens inevitably, and sometimes it happens, you will not lose the code on your personal computer because all your code will be living somewhere else on GitHub. That's what we're also going to be teaching you today. Harshit, do you have anything to add in here?
Nope, I think we can move on to installation now.
Okay, so to install Git, so installation is platform dependent. Okay, if you have Linux, then your operating system most probably already comes with Git. All right, if you have Mac, I'm actually going to show you now how to install it. So if you go to terminal, and then I already have Git here. So then when I type Git, you'll see this, right? It's a long message. If you don't have Git, you literally just open your terminal and type Git, and then it'll prompt you for a dialog that'll ask you, do you want to install these things? And then just click yes. All right, that's how you install Git on the Mac. And now Harshit will talk about how to install Git on Windows.
So if you go to the download section on the left of the page, you see download instructions for separate operating systems here. So you can go to the Windows section here. So Git offers a Git Windows, a Git GUI, as well as a Git command line interface for Windows. However, we'll be covering the command line part here because it is same across all operating systems. But if you feel more comfortable with the GUI, you can also use that. However, to install both of them, you can just take the 64-bit Git for Windows setup from here and go through the installation wizard like any other Windows wizard. And most of the settings can be used as the default ones. And you can just keep going through the wizard and it will install Git for you in a short while. After that, you can keep using Git commands from your PowerShell command line or even Git bash, like you can do on Linux or Mac. Josh will cover the commands later, but they can be used just like you do on Windows or just like you do on Mac as on Windows.
All right. So that's how you have Git up and running on all three major platforms. You have Linux, you have Mac, you have Windows. So by now you hopefully have Git installed on your system. And now we'll walk you through how to actually use that software. So the idea about Git is that, so ideally or plainly, Git can run on your laptop only, okay? The core function of Git is for you to be able to revert to a back version of your code. And so in the most basic setup, Git backs up all those versions of your code on your personal laptop or on whatever machine you're writing your code on. So, but then that is called a local repository. Okay, repository basically means a collection of your code. And so then people thought, why don't we, because we are aiming for robustness, why don't we back up all our code in a cloud server? And that will have the added benefit, as I explained, that when your computer dies, you will not have to worry about losing your code just because it lives on a single computer. And so what happens there is your code lives on what's called GitHub. GitHub is a remote provision of Git. Git does not need GitHub, okay? So even if there's no GitHub, Git can still work, but then it will still only live on your laptop. So then even though you can still back up to your past versions of your code, your code lives and dies with your computer. So GitHub is really like a bonus to Git, where you can have your Git provision your code or store your code rather on the remote server, which is not necessary, but is incredibly useful. So today we're going to teach you how to operate on Git with GitHub. All right, so what you do there is go to github.com. So once we go there, you see this is my home screen on github.com. And if you have not logged in on your laptop onto GitHub, then you will see a fancy screen that's showing a rotating Earth, also showing a bunch of fancy lines that connect dots on the planet. But all you need to care about is to register for a new account on that page. All right, and we're not going to walk you through there because you already know how to do it. It's just register an account with your email. Okay, so now you have an account. Here's what you're going to see. All right, and so what you want to do is try cloning a repository. All right, let's just say I want to clone the one repository I wrote, which is actually a Vim plugin. I highly recommend if you use Vim to try this out. So let's clone over it. All right, so how you clone code. So first of all, what is meant by cloning code? It literally means download. Okay, cloning just means download. So how do you clone it? You click on this green button here that says code. And then now you see three options for cloning the code. All right, you have HTTPS, you have SSH, you have GitHub CLI. For security reasons and for general purpose reasons, we recommend cloning or operating on any functionality on SSH. Okay, HTTPS can work, but then it's less secure, and also just because if it's less secure, GitHub is moving away from it. So in the future, this function might be obsolete. SSH is secure and it's fast and it's password free. You don't need to type your password every time. GitHub CLI is something invented by GitHub. Okay, so you see how the command here actually starts with GH, which stands for GitHub and not Git. So then this is actually platform dependent and you don't want that. So we recommend doing everything on SSH here. And all right, here. So what you want to do in order to clone this code, clone this repository, is to click on this button, which copies whatever this is. All right, so I copy it. And now go to your terminal. And remember, you have your Git installed, right? So we just literally type git clone, and then you type this repository name. And now you hit enter, but then, hey, it says you do not have the permission to read from the remote repository. And that is because in order to operate on SSH, you need to have an SSH key set up in your GitHub account. So then your computer knows to use that key to authenticate you for SSH. So an added step that's very much needed here is to set up an SSH key with your GitHub account. So how do we do that? All right, let's type in Google search bar. Let's just say GitHub generate a new SSH key. Okay, and the first thing that comes up is this page, and just click into it. And all right, so here comes the part where the instructions for the three platforms are a little different. They're not drastically different, but then some things are different. So I'm going to walk over how to do that on a Mac, which is 99% the same as what you would do on Linux. And then later, Harshit is going to cover how to do that on Windows. However, do know that these instructions are very detailed, as you can see. And even without us, I'm sure that people will be able to follow those. But just for the sake of instruction, I'm going to walk over how to do that in this occasion. All right. So what you do to set up a SSH key is, first of all, run this command on your terminal. I'm going to do that now. Be sure to switch in this email here with your email, which is associated with your GitHub account. In this case, I'm going to type my email. All right. So here it wants me to enter a file in which to save the key. And it has a default name. You can use that name. There's no problem at all with that. But then I'm just going to type my own name. All right. Let's just put it in the default repository location, and then I'm just going to call it the same as my GitHub username. All right. So here, for passphrase, you can skip that, or if you want to use it, that's fine. But then for the sake of simplicity, I'm just going to skip it. All right. So here is my key. It is dangerous to expose this out on the internet, which is what I'm doing now. But then after this tutorial is set up, I'm actually going to delete this key, so then you can't hack into my account. But if you're doing this on your own, do not show your key to anyone. All right, that's like a basic security measure. All right, so now you want to add your SSH key to the SSH agent on your computer. So you run this command. And then if you are using this particular version of macOS, then you need to add certain lines in your SSH agent. So in this case, I already have this file. So I'm just going to open this file. I think I stopped the screen share here. So I'm going to open it back up. All right. So now you see my terminal. I will add in these lines that the GitHub instruction tells me to add into my file. All right, so now the identity file, it actually is the default name of where to save that that SSH key file. So because I typed in a custom name, I'm actually going to change that. All right. Let's just make sure that it's there. All right, cool. So then this is complete, and I'm going to save this. All right. So now I'm going to add this SSH key to my SSH agent. And you might not know what an SSH agent is. It doesn't matter. It just means that your computer that knows that there's such a key. All right. So I'm going to run this command. Again, switching this default key name with my actual key name. All right. So it says the identity is added. And also here, depending on the version of your operating system, this step might see a bunch of errors, but then all of these error shooting information is right here. So then you can actually go on this page and have a look. Okay, cool. So now we have generated an SSH key. We can click on this link that says add this to my GitHub account. You do not need to generate a key for a hardware security key. Okay, that is something extra. So now click on this. And you want to copy the content of your SSH public key. Okay, so I run this command. Again, switching in this this portion for my custom name. Okay, now it's copied. I will do what this says, basically go on GitHub. And then it tells me to go on this button that says settings. All right, you can see this is my GitHub settings. And then I will click on SSH and GPG keys. And I will add a new SSH key. Okay. And here. For the title, I can literally say anything, but then I'm just going to type the name of the key. Okay. And for the key type, you can just use the default. And for your key, you will literally press Command V to paste what you have on your system clipboard to here. So now you add in your SSH key. All right. So now your key is here. And then hopefully you can use the existing key on your laptop to authenticate you for all GitHub actions. Okay. So here, let's try SSH git at github.com. All right, it says my authentication has succeeded. Now let's try cloning this repository that we just tried a minute ago and failed. Remember, because I didn't have the necessary access or privilege to view it. Now let's try cloning it again. You can just do this whenever, but then I'm actually going to here. All right. So I'm gonna say git clone and paste that name over here. All right. So now you can see that it actually successfully clones this remote repository, right? So that means that we have successfully added our SSH key to our account. So then we can freely do anything we want on GitHub with Git. All right. So now that we have covered how to set up your GitHub account, we have covered how to add an SSH key, which really activates your GitHub account. Now we can actually talk about how to use Git for all sorts of purposes.
Before we move to that, so what Josh just did was clone a repo, and now the entire code is downloaded onto his laptop into what is called a local repository. So what you see right now on the screen is the remote repository, which is like the ground truth, the North Star truth of the code. But what lives on his laptop is the local copy, which is called local repository. So whenever from now on he'll be using the terms local and remote, you know what he's referring to. So now I'm going to show you how to add the SSH keys to GitHub on Windows. So the instructions are fairly similar to those on Mac as Josh had demonstrated before this. So we'll quickly go through them. So to begin with, I've already installed Git on Windows, as I briefly told you about. From this page, I had downloaded the 64-bit Git for Windows setup, and I've already installed it. So after you do that, you have Git Bash and Git GUI both on your desktop. And for the purpose of adding an SSH key, we'll be using Git Bash. Before that, let's see the page for the instructions. So this is the same page that Josh had been using for Mac. You can use the same page and go to Windows. So first of all, it asks us to open Git Bash. So that's what we're going to do. See, open Git Bash. So Git Bash is basically kind of a Linux bash shell, which already has Git capabilities, and a lot of the traditional bash commands do work in this shell. So anytime you want to use Linux commands in Windows, this is one good option. So yeah, we'll start off by generating a new SSH key using this command. Again, it's similar to the one that we used on Mac. You have to be mindful to change your email address here. Just add your primary email address that you have configured in GitHub. Once again, it asks us for the file name with which we want to save our SSH key. So so you have to type the full path. You can copy the leading path from what is given in the default one. And we can just leave the passphrase empty for now. So yeah, the SSH key has been generated. The next step would be to add it in the SSH agent. So first of all, we'll start the SSH agent using this command. That's done. Now the next step is to add the key that we created in the first step to the SSH agent. So to do that, we'll just replace the default name with the name that we gave, which was GitHub _ Harsha2997. So we'll just take that and put it here. And the command we had copied from the instructions page. So this will add the identity to the SSH agent. We don't need to follow the hardware security key steps. The next step would be to add the SSH key to the GitHub account. And this is very similar to what we did in the case of Mac. It's just that the command to copy the key to the clipboard is different. Here the command is clip. So we take that here. And once again, we'll change the name of the SSH key. This would copy the entire key onto my clipboard. And then I can just go to the SSH and GPG keys page. Where do I get it from? I go to the top right icon. Then I go to settings. And in the left pane, I go to SSH and GPG keys. And I go to adding a new SSH key. I can give it any name. I'll just use the same name that I gave it on my local computer. And I can just copy the key here with the key type as authentication key. And I can then add the SSH key here. Now I can clone any repository comfortably. So I already have cloning command ready here. So I've been able to clone it successfully since I have the SSH connection wired up. So this is how you configure SSH on your Windows machine for using Git. And now Josh will take you through using Git through the command line.
Right. So let's now go over how to set up GitHub in a way that will help you organize your code for this course. All right. So remember, Git is used for keeping track of versions of your code. So you need a repository to keep track of all your code, just basically store all your code in, right? And you need a private repository for that. And how do you create a repository? You literally go to the github.com front page. And then there's this green button that says new, just click on that. So now you are creating a new repository. And let's just say IDL test for the name of this repository. You don't need to put any description. It's entirely optional. It doesn't do anything. It's just purely a matter of aesthetics. Here, you have the choice of creating it to be a public repository or a private repository. We want it to be private because of obvious reasons, right? It explains here. If it's public, anyone can see it, and that's going to be an issue. You don't want your code to be seen by other people. In general, right? Course policies apply in greater granularity, and you might find in some occasions that you're permitted to see each other's code / having each other see your code. But then for a general purpose, you should create a private repository. Okay, so you don't need to add a README file, although you could. This is purely a matter of personal choice. It doesn't mean anything here. I'm just gonna skip that. Again, this one, same deal. I'm just gonna skip it. License, same thing. So what happens with licenses is that since a lot of open source software is hosted on GitHub, the license basically tells people whether they can use that software, which they have the source code of in ways that they see fit. Since this is not real, software that other people can use, this is really your homework code. Also, you're the only one really seeing this repository. I'm just going to skip that. Okay, so now I click on this green button that says create repository. Okay, so now I have a repository, but amazingly, this is empty, right? It doesn't have any deep learning code in it. Bummer. So what do? Is I first clone it to my local laptop. So I have the choice again of cloning it over HTTPS or SSH. I'm going to choose SSH here. That's what we set up the SSH key for. Now we click on this button that copies the the GitHub address of this repository, and then we go to our terminal. Oh, by the way, I'm gonna just remove this entirely. All right, so I'm gonna say git clone, and then this. All right. Okay. So now I have this this folder that's called IDL test. I'm gonna go in there. So now you can see that there is absolutely nothing in there except for this folder called .git. All right. You do not want to remove. You do not want to remove this Git folder because it contains information about past versions of your code. And also it links up your local repository to the remote interface that you see on github.com. If you remove this, then this connection will be lost. All right, you can still clone it from the cloud, from GitHub, but then your local provision of your code will be completely standalone. All right, so you do not want to remove this. I did not run that. Okay, so now what we do is, let's say we create a new file, right? Let's say we write some code. So let's say homework 1. Let's write some code. Okay. We can see the code works. So what we do is we do what's called add, commit, and push. Okay, so we first do git add file name, and then we do git status. We know that there is a new file that Git recognizes. Because if we don't add it, Git will not recognize this file at all. It will just not see it. But now we added it, so Git knows that there's a new file, and then we will commit it. Okay, so the format for the commit command is literally you say git space commit space -m, m standing for message, space, and then a message that's surrounded by a single quote. Okay, and the reason why you want to commit is that you want to save checkpoints in your code that's spaced out in a reasonable interval, right? You do not want Git to create a checkpoint off of every single line of code you wrote. In that way, if you want to revert to a back version that is actually meaningful to you, you will not know which checkpoint it is because you will just have way too many checkpoints. And each commit creates one single checkpoint. So now when you reference code in the past, you will reference them by commits. And if you don't commit, let's say you just add files and don't commit. If you don't commit, you will not have anything to revert back to. Okay, so revert. So commit is really the essence of anything you do. So now if you do git log, you will notice that I have already made one commit. And so what you now do is git push. Okay. Now you see that this code lives on the remote repository. So push really means pushing your code to the remote provision. So now this code lives on the cloud. It lives on GitHub. And even if you delete every line of code that's in here, it doesn't matter because the code is up there. All right. So now to make sure of this, let's go to this this web page that hosts our repo, and let's refresh the page. And let's see, our code is here. All right. So we really know that the code that we have written is on here after we run these 3 commands, right? Add, commit, and push. All right. So we can change the file.
Josh, just one more small thing. So when you do git add, what you do is you basically stage a change, which basically means you make the change ready to be committed, but it's not necessary that you have to stage all the changes. So here Josh created only one file. Had he created homework1.py and homework2.py, he only did git add homework1.py. So homework2.py won't be committed. Only homework1.py would be committed when he does the git commit thing. So there is something called a staging area. So when you do git add, then only the files that you pass in the git add arguments go to the staging area and are ready to be committed. The other changes are still unstaged, and you can keep modifying them and they won't be committed.
That's true. Okay. Right. So, yeah, the adding and committing, really, you can only commit what is added, right? So let's say I have a bunch of other files in this repository. I'm not going to actually demonstrate that, but if I have a bunch of other files, you can try it on your own, create 100 files and only add, homework1.py, and you commit it, and only the one file that you added, which is homework1.py, will be on the remote repository, which is on the web page. So that you know that if you don't add a file, even if it exists here, it will not get committed and hence will not be part of the Git record that you can later revert to. Okay, so now let's try changing the file in such a way that it messes up. And now let's try reverting the file to the previous commit. Okay, let's say we mess up this file. So now the file is messed up. Now we want to revert to a previous version of our code, right? So if you type git status, you will see that Git actually recognizes that this file is being modified. And so what we want to do is revert it to a single version in the past, right? And how do we locate versions in the past? We do that by running git log. And so, okay, so here is our the complete list of all the commits that there has ever been in our Git repository. And you can see that each commit comes with a hash. A hash basically means a really long string that is uniquely identifiable with this commit. So what we do is we want to revert the homework1.py file to this hash, which means this commit, right? So what we do is we really just type out the first six characters of this commit hash. So we're going to say git checkout, and then the first six characters in there are F163E. All right, and then we type the file that we actually want to revert back to. So what this command does is it reverts this last argument, which is our file, to the second last argument, which is this commit. All right, so we check this out, and let's see what happens. All right, the file is back in where it was when we last committed it, and the extra code or the change in the code that messed it up is not there, right? So now our code works. So this is a very basic setup of how you, first of all, add, commit, and push the file so that your code lives on the remote repository. And it's also, now you know how to, when your code is messed up, how you revert to a previous version. All right. So there are other things to learn about in Git, such as branching, which is actually very important for if you're actually going to do serious software development. But for the purpose of IDL, I don't think there's a large use case for branching at all. So then there are a bunch of great internet tutorials on this. I encourage you to have a look at them. But for now, for the sake of this course, I think once you master how to create a private repository, how to add, commit, and push a file, and how to revert to back versions of some files, then you'll be fine. All right, Harshit, I think that's all I wanted to say. Do you have anything to add in here?
No, I think that will be enough for people to maintain their homework codes on GitHub. I don't think anything else should be required.
Cool. So good luck on the course. It's a heavy course, but I'm sure it'll be worth it. And please don't hesitate at all. If you have any questions, and please approach us either in person in office hours or on Piazza or via email or really by any means.
And just a small reminder, please create a private repository when you're trying to maintain your homework code. You don't want to land in trouble just for creating a public repository by mistake and someone else seeing your code. It's not worth it. So please keep in mind that you have to create a private repository.
All right, that's all we got today.